The James Webb Space Telescope, humanity's most advanced instrument for probing the depths of the cosmos, has once again delivered a revelation of monumental significance: exclusive, high-resolution images of Pluto that are fundamentally reshaping our understanding of this distant world. Long regarded as a frozen and lifeless relic at the edge of our solar system, Pluto has now emerged as a complex and dynamic celestial body teeming with secrets that defy previous scientific assumptions. The new data, both astonishing and perplexing, suggests the presence of hidden subsurface oceans, ongoing geological processes, and intricate organic chemistry that hint at the tantalizing possibility of extraterrestrial life. These revelations have left the scientific community in awe, and at the heart of this transformation lies Sputnik Planitia, the vast heart-shaped plain on Pluto's surface. What was once thought to be a simple stretch of frozen nitrogen ice is now believed to mask a colossal liquid ocean underneath, kept warm by insulation from a thick layer of ice above. This concealed ocean, if confirmed, could become one of the most significant findings in the search for life beyond Earth, offering a stable and protected environment where microbial organisms might potentially thrive. Pluto's surface continues to baffle researchers with its otherworldly features. Towering ice mountains rivaling the height of Earth's tallest peaks rise from the plains, while vast stretches of terrain remain eerily smooth, pointing to recent and perhaps ongoing geological activity. Such signs of dynamic movement were wholly unexpected for a celestial object once assumed to be inert and frozen in time. Beneath its icy shell, internal heat, likely generated by radioactive decay within Pluto's rocky core, drives a slow, lamp-like convection of nitrogen ice. This unexpected level of internal energy suggests that Pluto is far from dormant. It is geologically alive, pulsing with activity even in the frigid dark of the Kuiper Belt. As a result, Pluto now joins an elite group of icy worlds, including Jupiter's Europa and Saturn's Enceladus, that may harbor life-sustaining environments beneath their surfaces. The potential interaction between liquid water and organic compounds in such places challenges long-held beliefs about the conditions necessary for life and broadens the definition of habitable zones far beyond the traditional Goldilocks model. Adding to Pluto's allure is its peculiar gravitational relationship with its largest moon, Charon. The two bodies are nearly equal in size, creating a unique binary system in which each exerts significant gravitational pull on the other. This interaction generates internal heat on both worlds, possibly driving the geological and chemical changes observed on their surfaces. Charon itself presents a series of mysteries, from vast canyons to strange reddish stains, suggesting that it shares a deep and intertwined history with Pluto. Some scientists even hypothesize that material may be transferred between the two bodies, potentially resulting in a chemical exchange that could include the fundamental ingredients necessary for life. None of these groundbreaking discoveries would have been possible without the James Webb Space Telescope, whose powerful infrared capabilities have allowed scientists to peer through Pluto's icy exterior and detect signs of subsurface oceans and organic materials. Earlier missions like New Horizons provided a glimpse of Pluto's surface, but Webb's unprecedented sensitivity has opened an entirely new window into its interior structure and atmospheric composition. Through careful analysis of Pluto's atmosphere, Webb has revealed an unexpectedly rich and multi-layered environment. Despite being extremely thin, Pluto's atmosphere contains nitrogen, methane, and carbon dioxide, gases that interact to form layers of haze stretching hundreds of miles into space. As Pluto travels along its elongated orbit around the Sun, these gases undergo dramatic transformations. When closer to the Sun, surface ices sublimate into vapor, forming a temporary yet substantial atmosphere. As Pluto moves away and temperatures drop, this atmosphere condenses and refreezes onto the surface. This cyclical transformation is unique among known planetary bodies and offers scientists a rare chance to study atmospheric evolution under extreme conditions. One particularly compelling feature of Pluto's surface, and that of Charon, is the presence of reddish areas likely caused by tholins, organic molecules that form when ultraviolet radiation breaks down methane in the atmosphere. These compounds are more than mere pigments. They are believed to be precursors to life. The formation of tholins on Pluto hints at prebiotic chemistry that may parallel the early stages of organic evolution on Earth. Researchers are now deeply invested in understanding how tholins interact with the water ice and other organics beneath. Pluto's surface. Could these chemical reactions create the right conditions for the development of life? It's a question that science is now taking seriously. Among the most transformative findings is the likelihood of a vast subterranean ocean beneath Pluto's crust. Scientists believe that heat from radioactive decay within Pluto's interior keeps this ocean in a liquid state despite the planet's frigid exterior. Such environments, shielded from solar radiation and cosmic hazards, could theoretically support microbial life, just as deep-sea hydrothermal vents do on Earth. If similar conditions exist beneath Pluto's crust, entire ecosystems could be thriving in isolation, sustained by chemical energy rather than sunlight. Unveiling the details of Pluto's hidden ocean could forever alter our understanding of planetary habitability, proving that life doesn't require proximity to a star, but rather the right internal conditions. The James Webb Space Telescope has not only detected the thermal signatures that support this theory, but it has also revealed variations in Pluto's surface temperature and geological makeup, indicating the potential presence of underground reservoirs and tectonic shifts. The recent release of classified Webb data and high-resolution imagery has ignited a wave of excitement and speculation across the globe. Scientists, governments, and the general public are captivated by the evolving story of Pluto, and the implications stretch far beyond this dwarf planet alone. Once dismissed as a mere icy speck on the solar system's fringe, Pluto is now at the forefront of planetary science, reminding us of how little we truly understand about our cosmic neighborhood. As anticipation grows for future missions, the scientific community is preparing for the next phase of exploration, sending orbiters, landers, and perhaps even robotic submarines capable of plunging beneath Pluto's icy crust to investigate its ocean firsthand. Such missions, though technologically daunting, represent the next logical step in humanity's quest to uncover the mysteries of the solar system. These probes could provide direct evidence of extraterrestrial life and validate decades of speculation about the potential for biology in places previously thought uninhabitable. The possibility of exploring Pluto up close has never felt more real. While early missions like New Horizons provided only fleeting glimpses, next-generation spacecraft may linger in orbit, deploy surface rovers, or even melt through the crust to explore the oceanic depths. Scientists are already conceptualizing the designs for such missions, including heat-propelled, ice-penetrating probes and miniaturized submarines capable of navigating alien oceans. At the same time, Pluto's magnetic interactions are being closely scrutinized. Although it lacks a strong intrinsic magnetic field like Earth's, the James Webb Space Telescope has detected curious patterns of charged particles and energy signatures around the planet, likely the result of solar-wind interactions and exchanges with the surrounding Kuiper Belt. These phenomena offer new insights into how even small, distant bodies can engage with their stellar environment, and they provide critical data for understanding space weather in the outer solar system. Pluto's place in the cosmos is being reimagined. Each data point from the James Webb Space Telescope adds a new layer to the unfolding story, one that challenges not only our understanding of this icy world, but of planetary science as a whole. The revelations coming from Pluto are a vivid reminder that the universe is more dynamic, more mysterious, and more full of potential than we ever dared to imagine. As scientists continue to decode the information streaming back from Webb, they are preparing the foundation for future missions that will deepen our understanding even further. These missions may include not only orbiters and landers, but also technologies once reserved for science fiction, autonomous ice-melting probes, subterranean swimmers, and even aerial drones adapted for low-gravity exploration. Such advancements underscore how Pluto has become more than just a target of scientific curiosity. It has evolved into a proving ground for the kinds of technologies and strategies that will one day be used to explore exoplanets and other distant celestial bodies. In studying Pluto, we refine the tools that will eventually help us answer broader questions about life and the universe beyond our solar system. The excitement surrounding Pluto also has broader societal implications. Interest in this distant world is galvanizing public support for science, driving increased investment in STEM education, and reigniting a sense of wonder that transcends borders, languages, and generations. School children are now drawing pictures of Pluto with oceans and mountains, imagining alien life, and asking profound questions about existence. The narrative of Pluto has become a source of inspiration, reminding us that science is not merely a collection of facts, but a human story of discovery, perseverance, and imagination. In the end, the James Webb Space Telescope's revelations about Pluto may prove to be one of the defining moments of 21st century science. What started as a reclassification controversy has blossomed into one of the most compelling chapters in planetary exploration. Pluto, once exiled from the Planetary Club, has reclaimed a starring role in the grand cosmic drama. It is now a beacon at the edge of our solar system, not just reflecting sunlight from 3.7 billion miles away, but reflecting back to us our own endless desire to explore, to understand, and to reach farther than ever before. As the data continues to pour in, and as future missions take shape, one thing is certain: Pluto's story is far from over. In fact, it may just be beginning,